All right, so we start chapter 2 talking about solving equations. And this is the single most important topic in Algebra 1. If you don't get anything else out of this class, you need to at least be able to solve an equation when you leave here. There are a lot of other important things to know too, but this is the biggie. This is the basis of the foundation of all your other math classes that you're going to take. Okay? So we have to be able to solve an equation. So the point of today is we'll ease into it a little bit. We'll solve one-step, two-step equations. Fairly simple, stuff that you've seen before. So no reason to get too weirded out by it. Couple of tricks you're going to want to keep in mind, but basically pretty simple stuff. Okay? Let's get started. I always want to start with some good vocabulary. Want to make sure that we know our vocabulary terms so we can speak about this stuff intelligently, right? An equation, mathematical sentence that uses an equal sign. Just any mathematical sentence as long as it has an equal sign in it, okay? Equivalent equations. Now, equivalent equations are basically what we do when we solve an equation. We create a bunch of equivalent equations to make the original equation look the way we want. And these are equations that have the same solution. For example, 2x equals 10 and x equals 5. These are both equations. They both have an equal sign, and they are equivalent. They have the exact same solution, which is 5 for both of them. They just look different. It's a little bit easier to see the solution in this guy than it is to see the solution in that guy. So that's what we mean by equivalent equations. Okay? Isolate. If you ever see the word isolate, they ask you to isolate a variable. What they're telling you to do, asking you to do is to get the variable with the coefficient of 1 alone on one side of the equation. So we can only have, on one side of the equation, you're just going to have a variable and it's going to have a coefficient of 1. Okay? And the way we do that is we use inverse operations to get that done. Right? So they're operations that undo one another. So the inverse of addition is what? Right, subtraction, right? The inverse of multiplication is division, things like that. So we're always going to be using inverses. Okay? So some quick review for you. We need to simplify this expression. Take a second, get that done. You can stop the video, give it a shot, start it back up, and see how you did. Okay? So we're going to distribute first. Okay? Then we're going to combine like terms right here. And so make sure you get negative 13x minus 24. Okay? And there'll be times we may have to simplify one side of an equation before we can solve it. Okay? Same thing here. Give it a shot. See how you do. Okay? Combine like terms. Here and here, you're going to get x. Here and here, you're going to get minus 2, or negative 2, so x minus 2. Remember, the minuses and negatives are exactly the same thing. Okay? Try this guy. Okay, we're going to distribute here. 5 times 3h is 15h. 5 times 2 is 10. And then we're going to distribute here and here. And what you're distributing is you're distributing a negative 1. So we want to keep that in mind. Okay? So we get negative 3h plus 9. And then we have like terms here and here. And like terms here and here. So you get 12h plus 19. Okay? We'll come back to simplifying later. Now, solving for a variable. We want to isolate the variable to solve for it. That's what we mean. And when we do that, it's going to be a very step-by-step process, right? And after we decide, after we find the variable that we want to isolate, then we want to undo our addition and subtraction first. Then we undo multiplication and division. And it needs to be that way every time. We have to undo addition and subtraction first, and then undo multiplication and division. It's almost like you're doing PEMDAS in reverse. Okay? And we'll talk more about that as we start solving more complicated equations. Okay? So, let's give it a shot. Let's solve this first guy. Well, here's the variable that you want to isolate, this g. So if you have any addition or subtraction around it, then you want to undo that. So we have this plus 2. We want to undo that. And the way we undo that is we use subtraction, right? So we're going to subtract 2. And the reason why we subtract 2 is because 2 minus 2 is 0, and g plus 0 is g. And remember that the object here is to get the variable by itself. Now the variable is by itself. So we want to zero out any addition or subtraction. Now, because an equation is a scale, we always want to keep it balanced. Whatever I do to one side, I have to do the exact same thing to the other side to keep it balanced. So if I'm going to subtract 2 on the left-hand side, I've got to subtract 2 on the right-hand side. And negative 8 minus 2 is negative 10. Okay? So this guy and this guy are exactly the same equation. They're equivalent equations. They just look different. Like I said before, it's easier to see the solution in this guy than it is in this guy. But we've just created equivalent equations all the way down to where the solution was easier to see. That's all we're doing. Okay? Another example here. We want to get x by itself. We want to solve this equation. So there's our term that has x in it. Is there any addition or subtraction around this guy? No, of course not, right? But there is multiplication. That's the next thing we got to look for. This negative 6 and the x are being multiplied together. So the inverse of multiplication is division. So we're going to divide both sides of the equation by negative 6. And the reason why we do that is because negative 6 divided by negative 6 is 1. And that's what we want. We want our coefficient on our x to be 1. Now we don't typically write it. So when your coefficient is 1, we just drop it. We don't show it. Then we can simplify negative 27 over 6 and get negative 9 over 2. Remember, the negative sign in a fraction can go anywhere, the numerator, the denominator, or way out front. Doesn't make a difference. It all means the same thing. Okay? Next example here. Find the variable that you want to isolate. This guy's right here. Is there any addition or subtraction around it? The answer to that's no. There is division. And we want to undo division with multiplication. Since we're dividing by 3, we want to multiply by 3. And we got to do it to both sides. And the reason why we want to do that is because 3 divided by 3. So 3 would now be in the numerator. This 3 would be in the numerator. This 3 would be in the denominator. When you divide 3 by 3, you get 1. And that's what we want. With addition and subtraction, we want to get 0. We want to add out to 0. With multiplication and division, we want to do the opposite so that we get a 1 for our coefficient. Right-hand side, 5 times 3 is 15. And so we are done. Sorry for that bell. Okay? All right, try this one on your own. And start the video back up and see how you do. Okay, again, here's your variable that you want to isolate. Since we're dividing by 2 right now, we want to multiply by 2 to both sides. Those will divide out to 1. 2 times negative 9 is negative 18, and we're done. Okay, that's simple. What about this guy? We've got a fraction for a coefficient. So here's the variable that you want to isolate. We're multiplying it by 2/3 right now. So your first thought might be to divide by 2/3 because you undo multiplication with division. And that's true. But it looks weird. We don't write it like this. Dividing by a fraction is the same thing as, remember, multiplying by the reciprocal. So we're going to multiply both sides by 3 over 2. Now, when we do that, we can multiply straight across. 2 times 3 is 6. 3 times 2 is 6. And 6 divided by 6 is 1, and that's what we want. Over here we make 6 a fraction, and we want to talk about, we can simplify this diagonal. Divide them both by 2, and then multiply straight across. 3 times 3 is 9. 1 times 1 is 1. So you get 9 over 1, or just 9. Okay, and that's how you deal with your fraction coefficients. A little weird, but that's it. Okay? Try this guy. Stop the video, give it a shot. It's going to be a little tough, but try it, and then fix it if you need to when you start it back up. Start the video back up. Did you get -3 over 2? So we're going to multiply both sides by the reciprocal again. So -4 over 7. Got to take the negative with it. So we cross simplify. These 4's will divide each other out to 1. These 7's will divide each other out to 1. So you just get 1 times 1 in the numerator, 1 times 1 in the denominator. The negatives become positive, and so you get 1x, and that's what we want. Now the right-hand side, we're going to multiply by -4 over 7. And as you can see here, this diagonal simplified out, right? 4 divided by 4 is 1. 8 divided by 4 is 2. Sorry for that bell again. And so you get 2 and 1 here. And then this other diagonal here, divide them both by 7. You see you get 3 and 1. Now I'm going to multiply straight across. 3 times -1 is -3. 2 times 1 is 2. You get -3 over 2. A little bit more complicated, but not that bad. Okay? Solve this guy, stop the video, see how you do. Did you get 11 over 2? I hope that you do. We're going to add 3 to both sides, then divide both sides by 2, and you should get 11 over 2. Okay? Try this one. Okay, subtract 7 from both sides. Divide by -3. And B is 9. Okay? One more for you. Okay. Couple of things to be careful of with one like this. Here's our variable. That's what we want to isolate. Right? Now we look for addition and subtraction anywhere around it, and we do see the subtraction sign. So it might make it seem like you want to add something to both sides. But that's actually not the case. We have this 10 out here that we want it to go to 0. That way 0 minus 16m is just -16m, and we won't have anything over there except for just the variable, the term with the variable. So you have to think about it in that terms, right? How do I zero out 10? Well, I do that by subtracting 10 from both sides, right? So we're going to subtract 10 from both sides. And then the next thing I wanted to show you was to be very careful to bring this minus sign down as a negative for this 16. That gets dropped all the time, and you want to be really careful about that. Bring that minus sign down as a negative, so you get -16m equals 160. Then we divide both sides by -16 and get our -10. Okay? So you have to be really careful about some of these and really think about what it is that you're trying to do. Okay? All right. Up next, story problems. And we've got to get good at modeling a situation with an equation, a story problem with an equation. Okay? And there's a process to it that we need to get in the habit of doing. Number 10 is a pretty easy story problem, and you probably aren't going to want to do the process, but let's use an easy one to help us set up our habits for later. Number 2 says the bus you're using for the math field trip can hold 65 students. You have room for 13 more. How many students are already on the bus? Here's what I always do in the story problem. I try to figure out what it is I don't know, or what it is I'm trying to find. Right? And we're trying to find the number of students that are already on the bus. Since we don't know that, let that be your variable. So let it be x, right? That's the number of students already on the bus. And once you establish that, tell the world, right? Define it. Write it out. X is this. Okay? Now, we need to come up with our equation. Now, the bus will hold a total of 65 students. So, to find the total number of students the bus will hold, we've got to take number on, right, and then plus the additional. Okay? In other words, X is the number of students already on, and we know that we can add 13 more. And we know we're adding because it says it will hold 13 more. So X plus 13 has to equal the total it will hold, which is 65. There's your equation that you need to be able to set up and solve. So we subtract 13 from both sides, and we get 52. Okay? So the last part of this is to answer the question asked. How many students are already on the bus? And so we can say something like there are 52 students already on the bus. Okay? But we need to answer the question in a complete sentence. Like I said, I know this one was a little easy, and you could have done it in your head probably, but we're using it to set up a habit, a pattern. Okay? All right, so you got another one here. Give it a shot. Stop the video. Define your variable, write an equation, solve it, and then answer the question in a complete sentence. And then you can start the video back up and see how you did. Okay. What do we not know? How many hours the repair work took, right, or will take. So let that be X. Number of hours for repair. Okay. Now, the total bill, so the total cost is going to come from two parts. It's going to come from the labor plus the cost of the parts. So, the parts are $215. The total is $390. Now the labor, the cost for the labor was $35 per hour. And per is your clue to multiply. So 35x plus 215 equals 390. That's the equation you want to go solve. So subtract 215 right, to get 175, and then divide by 35 to get 5. And then to answer the question in a complete sentence, the repair took 5 hours. Could be as simple as that. Okay? All right. One more. And this one's a little bit tricky. So define your variable, come up with your equation, start the video back up and make sure your equation is the same as mine. And then we can solve it and write out a sentence. Okay, did you come up with this? So we don't know how many months he withdrew money. So, let that be X. Now, here's the situation. At the end of all the withdrawals that Ben has made, his balance from his trust fund is going to be $238,750. So his balance is going to come from how much he starts with minus how much he takes out, right? Well, he started with $250,000, and he's taken out $750 each month. That's another word, each and per. Each is another word. It lets you know that you're going to be multiplying two things together. So each month, X is the number of months, 750 is how much each month. We're going to multiply 750 times X. And we're subtracting that from 250, because when you withdraw, you're subtracting out money, right? So there's your equation. 250,000 minus 750x equals 238,750. And then you go through and solve. Right? So we get negative 750x equals negative 11,250. Then we divide both sides by negative 750. And so x ends up equaling, I believe it's 15. So Ben withdrew money for 15 months. Okay? Hopefully that makes sense. And story problems are tough. You're just going to have to try them. Keep trying them, mess them up, fix them, learn from it, and we'll figure them out soon enough. Okay? All right. Now, algebraic proofs. We've got one more thing we want to talk about. Algebraic proofs for solving an equation. Sometimes we want to lay out solving an equation in a proof format. We want to prove what we're doing. And the object behind a proof is to show exactly what it is you're doing, your step-by-steps, and then justify that with some kind of reason. Okay? And for right now, all of your reasons are going to come from properties or definitions. And if you want to write these down, the properties that you're going to use could be the addition property, and we can abbreviate it prop. Could be the subtraction property. Could be the multiplication property. Or you might use the division property. Okay? Now, you also are going to use given. And simplify. As possible reasons too, and I'll show you when to do that. Okay? So, we want to solve the equation basically. On the left-hand side, we're just going to solve our equation, and we're going to show every step in a lot of detail. The right-hand side, we're going to back up every step we make. Right? And we're trying to do this so that anyone who sees it knows exactly where everything's coming from. We're justifying all of our statements. Now, to get started, we can't start unless someone gives us an equation, right? I can sit here with in a two-column proof. I guess I ought to explain the format here. A lot of different ways to prove something. The most basic way is a two-column proof. Two-column proof, called that because you have two columns. Left-hand side are statements. Right-hand side are the reasons why you're making those statements. You're backing up your argument. Okay? So, the first step is we have to get an equation from somewhere. So someone's going to give it to us. So since we start with something that was given to us, that's the reason we're going to use for writing down the equation. 2x plus 7 equals 15. That's given. Just someone gave it to us. Okay? Now, all you got to do is solve the equation on the left-hand side and do it in a lot of detail. You can even go down and write down all your statements right now. But I'm going to show you statements and reasons as we go. Okay? So the first step in solving this equation is going to be subtracting 7 from both sides. You need to literally show that. Okay? And then the reason for that is going to be, well, since you're subtracting 7, the subtraction property. Okay? Then, from there, we would simplify each side of the equation. I would actually combine your like terms, or however you want to look at it, and we would get 2x plus 8. 7 minus 7 is 0. 15 minus 7 is 8. And since we're simplifying to get that, that's the reason we're going to use. We're just simplifying. Okay? The next step into solving this equation is going to be divide by 2, right? Since we're dividing by 2, our reason is simply going to be the division property. Okay? And then when we actually divide everything out to get x equals 4, we're simplifying. And it's really that simple. Okay? There's not a whole lot more to it than that. So we got one more for you to practice on. I'll give you a few seconds to write your statements and reasons in. And then you can check as we go. First reason. Right? Well, someone had to give us the equation, so that's going to be given. What would you do first to start to solve this equation? Well, hopefully you're saying you would subtract 5 from both sides. We got to zero out that 5. And we're using the subtraction property for that, right? Then what happens? Well, we're going to actually subtract. So we get 24 equals negative 3x. And the reason why we did that is that we're just simplifying. And of course, from here we're going to divide both sides by negative 3 using the division property, right? And then from there we're going to actually divide everything out. We're going to simplify. Get x equals negative 8, and that's the reason we're going to use 2, is simplify. Okay? And that's it. That's all there is to these two column proofs. Okay? That's it. You have homework out in Canvas. Make sure you have that done by next class, and we'll see you guys then.